Firefox, short for Physical Phone Experiments, is an app designed to turn your iPhone into a tool for performing physics measurements and experiments. It allows you to use the sensors in your phone, like its accelerometer, microphone, gyroscope, barometer, magnometer, and light sensor for these experiments, so there's no need for additional equipment. Firefox has a vast collection of measurement categories, including raw sensors, acoustics, everyday life categories, mechanics, timers, and tools. Many of these are being shown below. A Firefox experiment can be controlled from any web browser, and the data collected can be downloaded directly onto any device. The data can then be exported and shared through any app on your phone. Firefox also has an experiment editor that allows you to customize and create your own experiments in the same way that the experiments available on the app were created. And although this is quite a complex process, this editor allows users to interact with the various components of an experiment and learn more about how your phone interacts with its environment. The rest of the experiment options are shown below, and all of them have YouTube tutorials and Wikipedia pages corresponding with the experiment that'll help users follow along. I decided to choose the pendulum measurement tool, which allows the user to use their phone as a pendulum. In order to get a more accurate reading, it is suggested that the user creates a pendulum that does not rotate. These can be little rotations within the pendulum that don't fully rotate the phone, or these can be full rotations where the phone begins to spin. Both of these will mess up the measurements. So I'm putting my iPhone into a Ziploc bag and attaching strings to the corners so that there's 2 strings in this pendulum and it does not rotate. While I finish getting this pendulum ready, let me tell you a little bit more about how Firefox is going to calculate and record these measurements. Firefox, as I swing the pendulum, will record the angular velocity of my iPhone, which should follow a sine function with the extreme values of its angular velocity being at the lowest points of the swing movement. The time between these maximum angular velocities at the lowest points in the swing movement will be taken as the pendulum's period, and its inverse as the oscillation frequency. Firefox is going to calculate these values by assuming a massless chord and a small angle approximation. So I'm using fishing line so my chord is as light as possible, and even though I will have wobbles, I should be able to get a pretty accurate reading if I don't swing the pendulum from very far back, because that's what the small angle approximation means. So the larger of an angle that I begin at, the higher my amplitude, the more uncertainty I'll have in my measurement. So Firefox recommends that you start with a small amplitude so we can get a more accurate measurement of both your gravitational constant, angular velocity, and the length of the string. To begin the experiment, I'm going to navigate to the pendulum section of the Firefox experiments. I'm then going to click on Time to Run. This will allow the experiment to begin once the pendulum is already in motion, so that Firefox can already start collecting the data, and my hand movements and influence on the system won't change the pendulum's angular velocity or period. I can then press Start, and Firefox will start collecting data for 10 seconds. After the 10 seconds, it'll display its measured and calculated values, and we can take a look at them. Here I noticed that Firefox stopped collecting data before the 10 seconds was up, indicating that they had all the information they needed. Here's a screen recording of Firefox as the experiment is occurring. Watch how the values change and eventually stabilize. One neat thing about the Firefox pendulum measurement tool is that it can calculate the distance from the point where the string is attached to a stand to the center of mass of my iPhone. So I'm going to measure this distance so I can compare it to Firefox's calculated value. Firefox can also calculate the gravitational constant g given my actual measured length, so I'm going to input it now. My measured length was 92.7 centimeters. We can see that when we input our true length, Firefox is calculating a value of g that's much lower than we know to be true. We'll go into that later, but for now let's look at some other neat features of this measurement tool. One being this graph where we can look at the amplitude plotted against the detected frequency. Here's this other graph where we can look at the period mapped against the frequency. This is known as autocorrelation. And here we can see the true angular velocities for each of the three axes. Pretty neat. For each of Firefox's experiments, there's an information section that helps you learn more about the experiment and how Firefox calculates it. You can always click on the video tab to go to their YouTube channel where there's playlists for how to perform each experiment. Here I'm looking at my angular velocity on my x-axis. It's a remarkable amount of data that Firefox can collect with just our phone sensors. You can click on each point in time and look at the angular velocity. Here I'm looking at the maximum angular velocities, which will be at the lowest point in the pendulum's motion. After reading more about how Firefox calculates this data and how smaller angles will offer less error, I'm going to perform an experiment where I do 3 trials measuring the gravitational constant g. In each trial, I will use a different starting amplitude with the amplitudes decreasing in each trial, and hopefully our value of g will get closer to the actual value, 9.81 meters per second squared. You can see that I've put in my actual measured value of my string length. This could be part of the reason for the difference in g calculations, because Firefox calculated a different string length than the one that I measured. You can see the timer above repeatedly begin on 3 seconds and then starting counting down from 10. The 3 seconds is the time period where I begin the pendulum's movement. It then swings for 3 seconds and Firefox begins the measurement, measuring for 10 seconds. As I mentioned before, this 3-second grace period allows for Firefox to begin measuring once your pendulum is free in motion. Here we can see how reducing the amplitude of our pendulum's motion can increase the accuracy of the experiment. My first experiment calculated a value of g of 9.3, my second 9.58, and third and fourth's 9.68. Definitely an increase. To get a more quantitative sense of the accuracy of the Firefox pendulum measurement tool, I'm going to perform a percent error calculation using the length that I measured with my tape measure and the length that Firefox calculated. While I do this calculation, I'd like to just take a moment to say that Firefox has over 70 videos on their YouTube channel where they go into different real-life applications of their app's features. They have videos showing how to use the app on a roller coaster, on a bike wheel in your car, walking around, all these different real-life applications of their measurement tools. It's really an incredible resource for students interested in physics and to get students interested in physics by connecting experiments and concepts to everyday life situations, and so that students can come home from a lecture and actually work on and connect what they learned in the lecture to their real lives. It's very impressive. I'm amazed at the accessibility of Firefox. To perform these measurements, most people would need advanced, expensive tools. But in this day and age, most people have iPhones, and the creators of Firefox have recognized that by creating their app, in which you can use the tools already in your iPhone to perform these experiments, you end up making physics measurements and physics experiments much more accessible. It's really amazing. Now I'm going to calculate my percent error using the calculated value of g that Firefox got and the value of g that we know to be accepted as 9.81. But while I do, let's go into the pros and cons of the Firefox app. Firstly, it's free to use, completely free. It's incredible. That's a big pro. Second, as I mentioned before, every sensor it utilizes is from your smartphone. There is no need for additional equipment. And thirdly, it's incredibly easy to use. And they have YouTube videos and tutorials for every single experiment you could think of, as well as tutorials for how to conduct your own experiments. There's not many cons, although it does drain your battery, and there can be sensor calibration issues sometimes. And there is a limited accuracy, and there's no really way to improve this accuracy because it's with smartphone sensors. But overall, I gotta give Firefox a 5 out of 5 stars. Our percent errors were 1.235 and 5.24%, which is pretty low for a homemade experiment. considering I also had a couple wobbles in my pendulum. Thank you, Fox.